Welcome to RIAPS Tutorial 1, Introduction and Hello World. This video is intended to introduce the RIAPS software component architecture and modeling language, and to demonstrate a simple Hello World application. We will introduce the concepts for writing distributed applications, event-triggered programs, and show the complete development and deployment process for a RIAPS application. Software can take many different forms, running on bare metal, within an operating system, even on many different devices. RIAPS applications are distributed applications, meaning parts of the program are run within an operating system on any number of devices all connected to a network. The application is not a single file with a main function running in one process, but can be any number of processes running in different places. We call these processes actors. Actors are themselves made up of components, which are collections of functions that can pass messages to other components, operate hardware devices, and perform computation. Components send and receive messages through ports. Ports that receive messages have special functions in their associated component file called handlers, functions that are called whenever that port receives a message. When component A sends a message to component B's port, it triggers that handler on B and is considered an event. This is part of what makes RIAPS support event-triggered behavior. We now know enough to make a simple RIAPS application. Let's start by opening Eclipse on the provided RIAPS virtual machine and creating a new RIAPS project. We start writing every RIAPS application by creating the model file, which defines what actors, components, and ports we want to use in our application. Doing this will save us time because we can generate skeleton code for our components. Start by creating a new model file with our project name, followed by .riaps. In the editor, declare your application with app, followed by the application name, followed by curly braces. In these braces, we will define all of our actors and components for the whole application. For this simple smart grid application, we'll just create a single actor called PMU, simulating a RIAPS actor that might run on a phase measurement unit. This actor will need a component to interact with the PMU hardware, so let's give the actor a PMU sampler component. Outside of the actor definition, we will further define the component. In order for this component to do anything, we need it to receive an event. We'll do this with a special port called a timer. By providing a period, say 1000 milliseconds, RIAPS infers this to be a periodic timer and will send a message to the timer's handler once every second. We now have a complete model of our application, so let's call the RIAPS Gen tool by right-clicking on our model file, finding RIAPS Tools, and clicking Generate Code. After a couple seconds, we need to refresh the project so Eclipse can find our generated files. Now on the left we can see a PMU sampler.py file. This is a skeleton component file written in Python. It already imports the necessary packages, creates a class for the component with constructor, and has the handler for the timer port already defined. All port handlers are named on_, then have the port name. This is the function called by the component's relative RIAPS actor on an event at this port. Let's use this timer handler to simulate sampling a PMU once every second. We first have to pull the message off the port to make sure it is removed from the underlying message queue, otherwise our timer handler will be immediately called again. Next, let's simulate a PMU measurement by generating a voltage and current measurement. Finally, we'll print this information out to the default component logger. Alright, we have a complete component and application. Now let's deploy it to a RIAPS node and see it running. We need to tell RIAPS which devices we want to deploy each actor to, so let's create a deployment file. Like with the model file, we create a new file with our application name ending in .depl. We again start with app, our application name, and curly braces. I have a RIAPS node running on 192.168.88.217, so I'm going to say on 192.168.88.217 in parentheses, and then the actor name PMU, followed by a semicolon. To view logging output in the default location, SSH into your RIAPS node and type sudo journalctl-u riaps-deplo.service-f. Alright, we have a model file declaring our components, complete component code, and a deployment file describing where we want our actors deployed. To deploy and run our application, start by opening a terminal on the RIAPS VM and running RIAPS_CTRL. In the RIAPS control GUI, let's select our application folder, then our model file, then our deployment file, and click Deploy. We see a row has been added in the control GUI with our application name. We can also see that my RIAPS node has been discovered by RIAPS control. When we click on our application in the GUI and click Launch, RIAPS control copies the application files from the provided application folder to the RIAPS node and starts the PMU actor. Now on the right, we see the application starting and logging PMU data once per second. You can stop your application by clicking on it in RIAPS control, then clicking Stop, and remove it using Remove. Make sure to remove all applications before closing RIAPS control. Congratulations, you have just written your first RIAPS application. Later videos will introduce better logging, more complex messaging patterns, devices, methods for handling faults, and more.